Okay, so we have converted a number to scientific notation. We have converted this scientific notation back to the normal, which is the standard form. So we will be using our scientific notation to do computation, right? So we will be multiplying some very large numbers by using scientific notation. So let me start with an example. You don't need to be able to read the number. So consider that we have 3. Okay, consider that large number. This number needs to be multiplied by another number which may be smaller. Okay, how do we do that? Now obviously if I take my calculator, this cannot fit there. The scientific calculator will not allow this amount of digits, but you could use scientific notation, and so you will need to use scientific notation to multiply this out. So here we go. Alright, so let's start. Now for us to work with such things, what we need to do is convert each one of these tiny number to scientific notation. We have done that. We have done a number to scientific notation. We have not multiplied them yet, but we can multiply them based on the knowledge that we have at this point. So let's convert this to scientific notation. So what do? We'll move the decimal point to the left for this one here until when we end up with 3.58 times 10. Why 3.58? Because this is then scientific notation. So let's move it. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 to the 12th power. Then this is times. We will need to move this to become 5.2 times 10 to the what power? Well, this will move to the right, so the power will be negative. 1, 2, 3, 4 to a negative 4 power. And that is how we have set up the numbers now to be work with scientific notation. Now, how are we going to work this out? Well, let's take them piece by piece. We will group the type of numbers with the same type. We're going to say 3.58. This will be times 5.2 open close bracket, and we put 10 to the 12th power times 10 to the negative 4 power. This piece here, recall the law of indices that says a base to a power times that base to different power. We'll keep the base and simply add their powers. So that's what we'll do here. Unlike this one here, you will need to multiply it out. So when we take 3.58 times 5.2, that will give us 18.616 times 10, 12 plus negative 4, which is then 18.616 times 10 to the 8th power. Now, is this scientific notation? No. We need to get it in this form as scientific notation. There can only be one digit at the front or to the left hand side. Hence, what we need to do here now is move the decimal point. So let's move this decimal point. So for this 10 to the 8th power, I'm going to keep it in blue. Alright? And I'm going to move my decimal point here 1. So this becomes 1.8616 times 10 to the first power. Alright? And now I must recall again the law of indices that says that if you have two bases which are alike and they are being multiplied, you will keep the base and simply add their powers, and that's what I need to do here. So this becomes now 1.8616 times 10 to the 1 plus 8, which is 1.8616 times 10 to the 9th power. I've shown you all of the steps that you need to do here. This is now the answer in scientific notation. If it was not asked to be done in scientific notation, then you would have a large amount of zeros, or this would still be okay, right? But this is scientific notation if you need to state your answer in scientific notation. So this is how you work this out. Now, Let's consider another scenario. Okay, and in this case we'll have multiplication and division. So this is our other example. Consider that we have now 1.6 times 10 to the third power over 0 point, now let me put 4.0 times 10 to the 12th power. Okay, so we're about to start with this number here. Let me write this much better. This is 4.0. Okay, so how do you work this out? Well, don't frighten yourself. Let's work them piece by piece. Work the numbers with numbers of its same kind. What you will do here is as follows. You will take these numbers here, work with them, and these are numbers separately. So you put here now 1.6 over 4.0 times 10 to the third power over 10 to the 12th power. Recall for here that a base to a power divided by that base to different power will keep the base and subtract their powers. That's what we need to recall here. Okay, so be careful with this sign here, it may be negative at times. So we do that. So when we take 1.6, and divide that by 4, we end up with 0.4 times 10 to the third power minus 12. This now gives me 0.4 times 10 to the negative 9 power. All right, now is that in scientific notation? No, because the number here needs to be between 1 and 10, so I must move my decimal point to my right. When I move it to my right, I will gain a base 10 also. So let me bring down this 10 to the 9 power, negative 9 power there, just to show you that what I'm doing right now is I'm moving this decimal point here. So when I move this decimal point, it ends up to 4 times 10 to the negative 1. Move that to one place, because 4, and we can put 0.0. Okay, that is still okay. So it becomes this. Now apply the laws of indices. A base to a power times that base to the different power will keep the base and simply add their powers. So we do that. We end up with 4.0 times 10 negative 1 plus negative 9, and that is going to give me 4.0 times 10 to the negative 10 power. Okay, so that's how we get this in scientific notation. So this number, which were in scientific notation, work out to this, which is the scientific notation solution. All right, so that's how we get those numbers in scientific notation. Now note carefully what we did here. We multiplied and then divide. Here we multiplied two standard numbers, converting them to scientific notation, and then when we thought it was finished, we need to convert still the other value to scientific notation, so we end up with a final scientific notation for our problem there. Okay.